because we last talked about it 2 days ago, which may seem like a long time ago, but the concepts still apply. So today is day one of JavaScript. We'll be doing 3 days on JavaScript. JavaScript, as we mentioned earlier, it's kind of like the we call it the nervous system of the website, but really what it does is it's just like a really powerful tool for doing a lot of computation and taking actions, right? Most of what we've done so far with HTML and CSS have been fairly static in the sense that we create things and then other people look at them. Well, JavaScript actually allows us to be able to interact with the different components, so it can detect not only what you do but respond to it, and then you can respond to that, and so on and so forth. So, just to kind of recap what we talked about earlier with what is programming, JavaScript is really where this concept comes into play. Talking about taking input, so we give the JavaScript code something, and then it will take a look at it, modify it, and give us back the result that we want. Okay, and that's a practice that we haven't really quite seen with HTML and CSS, but we definitely will with JavaScript and object-oriented programming in general. It's very logical and has a lot of decision making, and we can do it at scale. So we're dealing more and more with kind of complex, high volume decisions and actions. And then lastly, because the code is more, or because the programming is a little bit more algorithmic and a little bit more complex, we want you guys to kind of be even more collaborative when you guys work together. And then lastly, what you'll notice very quickly is that for almost all of the problems that we'll do from here on out, there is many ways to do the same thing, right? There's no quote unquote right way all the time. So before we get started on writing the code itself, one notion that we just want to make sure that you guys are kind of aware of is when most people think of programmers, they think of the programmer writing, like cranking away on their keyboard, writing a lot of code. But the reality is an average programmer probably spends, I would probably say, less than a third of their time kind of writing new big chunks of code. Instead, what they actually do is there's a lot of reading and understanding first before you start writing code, and then a lot of testing afterwards. So before you start writing code, the best, not the best, but the most crucial thing to do is actually understand how your code is going to fit in with what's already been written, right? What's already there. So if I worked at Facebook and someone said, "Hey David, can you build a like feature for Facebook?" Well, the first thing I would do would not be just jump in and start writing code. I would actually take a look at the existing Facebook code and understand where does my product fit in, right? If my product was not to work, the best case scenario would be Facebook launches a feature and the like feature just doesn't work. The worst case scenario is I take down all of Facebook, right? And so comparing against those two outcomes, it becomes very clear why it's really imperative for us that before we write any code, we must first understand how it interacts with the rest of the code, and more importantly, making sure that it doesn't break the pre-existing code. The next thing we have to do is then understand how we're going to approach a problem, right? The analogy I always give here is when you build a house, you almost always draw a blueprint beforehand, so you know where the walls go, where the foundation goes, and where the rooms are aligned to one another. If you don't plan ahead, then basically what you're saying is, I'm gonna build a house by taking a board, taking another board, I'm gonna start nailing them together, and by the end of it, I hope that I have a house. Like after I just kind of chaotically do everything, right? That may sound silly as an example for building a house, but actually that's kind of like how a lot of people first write code when they first start out. They see a problem, and their first intuition is let me just start like writing code, and hopefully it'll take me to where I need to go. But the reality is writing code is actually not that hard. As with more practice, the typing itself, it actually becomes very simple, right? For example, everyone here probably has a pretty good mastery of the English language, but if I asked you to write something really hard, the hard part isn't the writing the English part, right? It's the making sure you have the right thoughts and research and alignment of the facts. So as you program more and more, you'll quickly get a sense that before you start solving any problem, always make sure that you're aware of how you're going to be solving it. It will make everything else a lot easier. And then once you finish writing the code, there's a debugging process and testing process. Basically, can you fix the code to make sure that you've captured all the scenarios and it does exactly what you want it to do? Whenever you write new code, it almost always has gaps or blind spots that you didn't foresee, right? And in fact, it's to the extent where if you write code, a bunch of new code, and it works perfectly the first time around, you'll probably be pretty suspicious, or at least a lot of developers will be very suspicious. You expect things to break, and your value there is to make sure that you understand what broke and understand how to fix them and prevent it from happening again later on. And in fact, most of the time, if you think about like a timeline of a new product being built, very little of the time may be spent on actually writing the code itself. And that amount of time is usually dwarfed by the amount of time people spend either kind of planning how to write the code and then testing the code and making sure that it works as expected after it's already been written. Which then brings us to this idea of pseudocode. Pseudocode is not necessarily a brand new thing. It's just a way of thinking about writing, about thinking about kind of crafting your solution before you start writing it in real code. Before we write anything, we always want to figure out what is the purpose of this program that I'm about to write, and then how will this program actually solve this problem. Sounds simple, but it's actually something that a lot of people don't do when they're starting off writing code. So here's just some examples of apps that I want to build, and then the problem itself seems very kind of easy when I tell you about it or tell the human about it. But before I start building any of this, I actually need to think about how I want to carry this out step by step. So what is pseudocode? Pseudocode then is an informal set of instructions that describes how a program is supposed to operate. It's not quite code, it's actually more like a very detailed set of instructions that hopefully helps you clarify your way of thinking around the solution. So let's take a look at an example. If I build a robot and I want this robot to make coffee, well, telling it to go make coffee will not be enough. I can go to Starbucks and tell a barista, hey, can you make me some coffee? And they'll know what to do, right? But a robot wouldn't really know what make coffee means. So instead, what I have to do is I actually give this robot a very clear set of instructions that may be far more detailed than what I think is necessary. But it actually is necessary if I start thinking about it from the perspective of a computer, which is that I have no prior context. I actually need you to tell me exactly what to do at every step of the way. And so here's like, a 10-step process for how to make coffee. And indeed, we can probably break some of these steps down into even more steps. The goal here is not to say, oh, like, let's spend all our time, just kind of going into minute detail on crafting instructions that we're not going to write as code. But really, the goal here is to say, okay, making coffee is going to be a 10-step process. If I want to make a robot that's able to make coffee, well, then I actually need to program it to do these 10 things, right? And each one of these things may be a step in of itself. It's just a way to break down maybe a larger, more complex problem into a smaller problem. But by doing so, you're also creating the blueprint for how to solve that larger problem. Okay. So if we do a quick example here, let's say I have a robot and I wanted to clean all 4 squares in this room. Well, if I tell the robot just go clean all 4 squares, it may not quite know how to do that, right? It's a little bit of an ambiguous instructions. However, what if I wrote some pseudocode for it? I.e., what if I give it a very simple 4-step process that it can actually follow over and over again to try to accomplish its goal? The 4-step process is very simple. Step 1, clean the current square that you're on. Step 2, look at all the other possible squares you can move to. Step 3, if one of those squares has a piece of dirt where it is a dirty area, go to that area and then go back to step 1. If there is more than one area that's dirty, just pick one at random. And then step 4, if there's nothing dirty there, then we're done, right? We've cleaned up the entire area. So if we go back to our robot here, let's actually follow that 4-step process through and see what happens. Step 1, let's clean our current square, and we did. Step 2, let's take a look at other squares we can go to. Well, we can go to any of the 2 adjacent squares that we're next to, right? And they both have dirt on it. So in this scenario, what step 3 says is just pick one at random, and then go to step 1 all over again. So now we're back to step 1. What does step 1 do? Clean the current square. So we do. Let's take a look at all other possible squares we can go to. There's only one possible square, so we'll move there. Okay. Then we go back to step 1, and we do the same thing. We clean our current square. We look at other possible dirty squares. We see one other one. We go there. We go back to step 1 again. We clean the current square. We check to see if there are any other possible squares to go to. Nope, we've been to all the other squares, so there's no new squares. And then if there's no new squares, then we're done. And so by writing a very simple 4-step process, what I've really done is I've actually created a set of commands that the robot could follow over and over again to clean not just a 4-square area, but a much larger area if need be, right? And this is kind of the power of computers, that we don't need to, if I was playing this from the get-go and I say, I want you to clean these 4 squares, I might need to give it a direction for each individual square. But here, I'm actually not doing that. What I'm doing is I'm just giving it a set of instructions, and the computer, or the robot in this case, can do it as many times as it needs to clean as big of an area as it needs to. And so now I don't have to predetermine how much work I need to do beforehand. I'll let the computer figure it out on my behalf. And so on that note, we'll transition now into JavaScript, which is the language in which we'll be using to write a lot of these commands, and the brain of the website. Okay, so today we're going to talk about, primarily we're going to focus on data types in JavaScript, and more specifically, how to create values, how do we store values, and how do we make, or rather, how do we use these values going forward. So the history of JavaScript is a very, very quick primer. It was created in 1995 by someone who worked at Netscape. And in the 25-year sense, it's really exploded into one of the most common languages out there. JavaScript has changed a lot since it was first released 25 years ago. And there's a group called ECMA International, whose job it is more or less is to not just standardize JavaScript, but to update JavaScript. Well, why does JavaScript need updating? If you think about where the world's computing was 25 years ago and where it is now, clearly we want to add new support to JavaScript, right? We want to add new features and new functionalities that make it more powerful, and we also want to add new security features that make it more safe. And so the JavaScript that we use today is not very similar to the JavaScript that existed 25 years ago. But at the same time, it kind of is a good thing, because every time JavaScript goes through a change, it becomes safer and more powerful. And so that's a good thing for developers everywhere. JavaScript is also one of the most popular languages out there, and it has been for quite a few years now. And the main reason why is just because JavaScript is probably the only language that you can use across the entire stack. What do we mean when we say the entire stack? Well, typically when we think about a website or a web application, there's three parts, right? There's the part that the user sees. So if I use Facebook as an example, the front end then becomes my homepage, the photos my friend posts, my news feed, all the ads I see. That's the front end. That's the part that the user sees, right? And that's what we've been building so far with HTML and CSS. Then there's the back end of the app, the part that we don't see. So how does Facebook know who my friends are? How does it kind of predict which ads to serve me? How does it manage my friend relationships and my connections, right? Those are all things that are extremely powerful that allow Facebook to function, but they're not things that the user sees directly. And then lastly, there's a database component. How do we actually store all of the massive amounts of information that Facebook generates? And what makes JavaScript really powerful is that it's a language that can probably be used across all three of these areas. If we take another language, for example, something like Python, then we'll notice that with Python, we can actually only use it on the back end, or at least we definitely can't use it on the client side. And so JavaScript is powerful because it is able to be used across all three things. And so you don't have to change languages when you move across, from client side to the server side to the database. Then the question becomes, well, why don't we use JavaScript for everything? Well, it's the same reason why we don't use the same language for everything, right? People have different preferences. Different language has different pros and cons. And so we're by no means saying JavaScript is the best language or the most powerful language. What we are saying is that it is one of the most flexible languages. And when you're first learning programming, sometimes it's just easier to understand it's easier to learn the concepts and not get bogged down by the syntax of multiple languages. And that's why Full Stack chooses to teach JavaScript, because it is able to be used across the entire stack. And this is yeah. And so as web pages move more and more towards what we call single page applications, JavaScript becomes even more important, because single page applications require a lot of user engagement, right? When you want to click on a button, when I do something, I need a language that's powerful enough to handle that and quickly enough to be able to kind of get me a response. And so what JavaScript really does is it kind of shines there in allowing us to create very powerful single page applications. And so a lot of the most common things that we use every day are being created with JavaScript. And once again, it's only one language, so you don't have to switch languages when you move across the stack. Any questions before we now move on to the actual nuts and bolts of JavaScript by talking about data types? Cool. Well, if there are no other questions, we'll just move on ahead. Okay, the first thing we'll talk about are values and variables. They're a little bit related, and I think one of the like a lot of times I think people use these terms almost interchangeably, and it's fine. Most people know what you mean. Although we just want to be a little more precise when you're first starting off to make sure you don't get confused. Values are data types that have a specific purpose and an intrinsic behavior. Basically, values are kind of, and this sounds silly, the values that we're talking about here, right? The difference between a value and a variable is that the variable is more or less an identifier or a label for a value. So if we look at the code on the right-hand side here, on the first line, we're creating a variable called num of states, and we're doing it with the var keyword, var space. Notice how var shows up in a different color, and that's because var is what we call a reserved keyword. It's part of the JavaScript language. And so what that means is whenever I type var, JavaScript says, I know what you're trying to do here. You're trying to create a new variable. Okay. And so here when I use var and then space num of states, I am creating a variable called num of states. Now, just by creating it alone, that num of states has no value, right? It's just a variable. It's a label for nothing, for an unidentified value. But if I keep going with the code, then you notice then I follow up with an equal 50. The equal sign in JavaScript is an assignment operator, and it says whatever value is to the right of me, I am going to assign that value to the variable to the left of me. And so what var num of states equals 50 is saying is, let's create a variable called num of states, and let's assign the value of 50 to that variable. And so from here on out, whenever I use num of states, I'm actually using the value of 50. Similarly, on the next line down, var name equals George. That's us creating a variable called name and giving it a value or assigning it a value of the string George, right? A text string. And then lastly, on line 3, we're creating a variable called answer, and we're assigning it the value of false. So even though the values themselves are 50, George, and false, what we've really done is now we've just created kind of variables or representatives of that value that then we can use in the rest of our code. And you'll see why that's really powerful later on, right? It's because variables have two kind of powerful components. One is it makes it a lot easier for us to label information so we know what we're dealing with. And two is variables actually allow us to change the values more dynamically too. So if we want to create a variable, there's just a few syntax rules we have to follow. One is there cannot be any spaces in the variable name, so it has to be one contiguous alphanumeric value. It must begin with a letter, an underscore, or a dollar sign, and it can only contain numbers, underscores, letters, or dollar signs. It is case sensitive, and so, and we'll talk a little bit in the full-time curriculum, we'll talk a little bit more about what does it mean when we capitalize different parts of a variable. For now, just kind of keep it as single word variables and all in lowercase, and you should be fine. And then lastly, variable names cannot be reserved keywords, right? So you cannot have variables you cannot have variables that already have meaning within the JavaScript language itself. So var is an example of that. I can't have a variable called var. And then you can also create variables using either the let or the var keyword. In this curriculum, we won't talk too much about let or var, but we will dive more deeply into it in the full-time curriculum as well. So if those are the values, if that's like the relationship between values and variables, well, what kinds of values are there? And the answer is there's quite a few. You don't need to memorize this because we're going to go through most of these one by one. But just note that for today, we're going to be focused mostly on the left-hand side and do a really quick crash course on the object arrays and functions on the right-hand side. But we're going to talk about objects and functions in a lot more detail next Tuesday. Okay, so let's get underway here. The first one is something that's very simple, and hopefully we're all very comfortable with this, right? Just numbers. Numbers are a data type in JavaScript, and usually numbers are used to perform arithmetic operations. In our case, we won't ever go anywhere past addition, subtraction, multiplication, or division, although you can do almost any math operation you want, right? Like exponents, what else am I thinking about? Absolute values, etc. All of that is totally fine, but just numbers are numbers in JavaScript. And indeed, numbers in JavaScript are actually very flexible. If I want to do a decimal number, I just do 5.5, right, or 8.5. If I want to do a negative number, I just put a dash in front of it. JavaScript is very, very flexible in that way, and you can use any number that you want as long as JavaScript recognizes it as a number. The next thing we'll talk about is a string. A string is basically a series of characters that can either be enclosed by a single quotation mark or a double quotation mark. But the key thing here is that whatever quotation mark you use to open the string, you have to close it with the same quotation mark. That means you can't have a string that you start with a single parenthesis or single quotation mark and you end with a double quotation mark. JavaScript won't recognize that. It will say, oh, great, double quotation mark is part of your string. I'm going to look for the next single quotation mark before I actually end this string. So here on the first two lines, we've created two variables. One's called full stack, and we give it the string value of full stack. And on the second one, we create a variable called academy, and we give it the string value of academy. Concatenation then becomes a way for us to add strings together, right? Adding is sometimes a little bit misleading because we saw on the last slide, well, we add numbers, right? That's a mathematical operation. We're pretty clear on how that works. Adding strings is basically a different way of us saying is let's concatenate strings together. And that basically means let us shove these two strings together kind of end to end and create a single string. And indeed, on line 3 here in the code block, notice how when we add or we concatenate full stack and academy together, we get back the string full stack academy. And then lastly, every string also by default comes with something called the dot length property. And what that does is that will just tell you how many number of characters are in the string. And so if you have an empty string, i.e. a string with no characters, it will return 0. In this case, we have a string called full stack, and if we return the length of the string, the number is 9. Okay, just so you know, the length does not correspond to how many characters are in the variable. The length corresponds to how many characters are in the value. So in this case, we kind of luck out. Full stack is both the name of the variable, but also the value. But if the value in this case was just full, as in we say var full stack equals a string full, well, the length of that string would just be 4, right? Full. So just make a note there. The next data type that's actually very common, and we'll see a lot of this, especially when we talk about. Oh, sorry, was there a question?
Yeah, sorry. Could you repeat that last part again? You lost me in the link.
Sure. Sure. Sorry. We just what I'm saying is so here if I have a variable if I have a variable called full stack, and I set it equal to the string full. Full stack dot length is going to be the length. I also misspelled length. Okay. Full stack dot length is going to be the length. It's going to be how many characters are in the value, not how many characters are in the variable name. So this variable name has 9 letters. The value is only a string with 4 characters, and therefore when I do full stack dot length, I get back 4.
Oh, okay. Fair saying. Gotcha.
Yep. Good.
Thank you.
Yep. Yep. Any other questions up until this point?
I just have a quick question.
Yeah.
The keywords were null or undefined.
Yeah. We'll talk about that in 2 more slides.
Oh, okay, cool.
Yeah. Any other questions?
Just to follow up on that, there's actually a number of unique keywords that JavaScript will get angry at you if you use. These aren't just the only ones, so you'll potentially run into a few other ones in your adventures.
Yeah. Cool. Yeah. So let's just go through the rest of these data types, and hopefully you'll get to see a lot more of these kind of things come through, right? So speaking of reserved words, so there's another data type called Boolean data type. Booleans are very simple. They're binary data type, which means there's only 2 possible values, true and false, right? When a lot of people think about programming, they think of 1s and 0s, which is fairly accurate because that's all a computer is. It's a glorified, super processor of 1s and 0s. Well, 1s and 0s are kind of the easiest, the most simple choice we can make any computer or person make, right? This is either 1 or 0, true or false. And so the Boolean data type is created to kind of represent that dichotomy. Say there's only 2 possible values. Something is either true or something is definitely false. There is no maybe. There is no ambiguity here, right? And notice how even though true and false look like strings, there's no quotes around them, right? And that's what makes them different. And that's when you're dealing with a Boolean value as opposed to a string with the characters TRUE. And so because of that, true and false are also reserved keywords in JavaScript. They mean something, right? So you can't have a variable called true. You can have a variable with a value of true, but you can't have a variable called true, or you can have a variable called false. Okay? And with most reserved words in most code editors, if you type it out, it will show up a different color, so you'll kind of get a sense very quickly that, oh, I probably shouldn't be using this as a variable. Or JavaScript might just like say, hey, don't use this as a variable, I won't let you. And then last but not least, we do have nulls and undefineds. We won't talk too much about them in this curriculum. Just note that they are real, and they have very different meanings. Undefined essentially means something has been created, but we haven't given a value yet. And null means we've given it an explicit value of having no value, right? So it's a very slight nuance, but it is one that matters, especially when you're looking at a lot of times when you're looking at error outputs. But for now, we're not going to spend too much time on these two data types. Okay, the next one we'll talk about are arrays. Arrays are in another language. They're in Python, for example. They're called lists, which I think is actually a very good way of thinking about it. Arrays are just kind of like a container that holds a list of different things. We start an array with an opening bracket, and then we just add as many things as we want, right? So in this case here, in the example on this page, we've added 4 things. And notice how all 4 things are of different data types, right? In the first case, we have a true, which is a Boolean value because there's no quotes around it. And then with each value, we just separate it. We separate this value from the next value by a simple comma. So we do true and then comma, and then the string true, comma, the Boolean value false, comma, and then the number 22. And then we close the bracket. Oh, shoot, sorry, everyone. And then we close the bracket. Okay, and so this is basically a very simple list. You can think of an array as a list or a container of multiple different value types. Yeah, and so we won't talk too much about arrays in this particular curriculum, but just kind of know that they exist and they can be very handy when you're trying to kind of juggle or capture multiple values at once. Another data type that's also very common is something called an object. An object uses properties of keys and values, and essentially we call them key value pairs. That may sound confusing to you if that's the first time you've heard someone say that, but an analogy that actually works out very well is when we say an object is a collection of key value pairs, you can think of it as saying a dictionary is a collection of words and their definitions, right? If I think about what the purpose of a dictionary is, when I use a dictionary, I'm trying to get a definition for a word, and I look up the definition by that word. Similarly, in JavaScript, when I use an object, I'm trying to get a value, and the way for me to locate that value is by looking at the key that corresponds to that value. And so the syntax for writing a value is we have our open curly brace, if you see that on the far left, and then we end it with a closed curly brace. And everything in between is just a number of key value pairs. So here the property is cattywampus, and we have a colon which separates the property from the value or the key from the value. And sorry, just for nomenclature's sake, I use the word key and property interchangeably. They're the same thing. Okay, so cattywampus is both a property and a key. Okay, so we have the key, we have a colon, and then we have the value to the left of the colon, right? And this is saying the key is cattywampus, and the value associated with that key is SQ arrive. Okay, and if we want to add more key value pairs, we just put a comma after this and add another set of key value pairs. We'll do a deeper dive into objects next Tuesday. So for now, just kind of know that objects exist, but don't worry too much if you're not quite comfortable with how this looks. Okay, and then last but not least, the last thing we'll take a look at is functions. Functions are very powerful. They're basically what makes programs reusable for the most part. You can think of it as a reusable chunk of code, or you can think of it as like a recipe, right? It does the same thing over and over again, but depending on the inputs that we put, it might give us different outputs, right? And so if you think of a very silly example, if I have a cookie recipe, well, if I put white chocolate chips in there, I get back white chocolate chip cookies, right? If I put in dark chocolate chips, obviously I get dark chocolate chip cookies. The recipe doesn't change, but based on what I put in, I get different things coming out of it. And so functions are reusable pieces of code. And we will also do a deeper dive into functions on Tuesday. But the one thing I really want to stress when it comes to functions is that a function is like a recipe, right? Like I can create a recipe, but by the end of me creating a recipe, I don't, by definition, have cookies, right? I have to actually go follow the recipe and bake the cookies. In that same vein, whenever I make a function, it's not the same as me running that function. Okay, so when we look at the code on the right hand side here, in the first block of code, all we've done is make a function called bake cookies. We haven't actually run the function yet. We only run the function on the two subsequent lines, right? Bake cookies and we pass in chocolate and then 5, and then bake cookies and we pass in vanilla and 10. We'll talk more about what chocolate and 5 and vanilla and 10 means, but for now, just note that that function keyword in red there in the first box, that's a reserved keyword, and that's us trying to make a function. And then only after we've made the function can we then run or invoke the function. And we can only invoke a function by using the open and close parentheses. So if we look at the second block of code there in the middle, the one that says bake cookies, open parentheses, and then on the far right hand side, close parentheses, that's us actually running the function now. And so don't get confused. Making a function is different than running the function. And generally speaking, we only run the function after we've made the function. Yep, so cookie recipe abound. Okay. And then last but not least, because we've done this for every other language, we'll also talk about comments in JavaScript too. JavaScript comments are incredibly simple. If I just have a single line comment, I can just do \\\, and JavaScript will comment out everything from that point on to the end of the line. Like, so I can do it on line 1 as a standalone line, or I can do it on line 2 as the remainder of a line of code that I've already written. Or I can do it on lines 3, 4, and 5, where if I wanted to have a multi-line block of code, I can have a \** followed by a ***, and I can write as much code as I want in between, and the computer will more or less just ignore it. And that's pretty much it for me. So we've kind of just went through a whole bunch of data types, and you'll go through them more in the workshop today. But hopefully everything, at least at a high level, kind of makes sense, right? Like you can kind of imagine, what these variables are and kind of how you would use them in certain situations. Are there any questions before we break off for the workshop?